Hello students, in this module we are going to be exploring some Linux utilities which are not so much the kind of file utilities, file processing, awk, grep, and even some of the scripting that you have been doing these past couple of weeks. What we are going to do is look at how we can monitor some of the system resources in Linux. Linux offers a wide array, unsurprisingly, of tools and utilities that can be used for system security, for monitoring the system's processes, for monitoring disk space, for monitoring the network activity, and a lot of other things. Now, many of these commands, even though they're offered by Linux, cannot be executed by us as regular users because we do not have administrator capabilities. So we will just look at some simple commands that we are able to do. And in that, what I'd like to cover in this video is some commands that we can use to do some file processing and cleanup, look at disk space, and then also to see how we can monitor system processes, how we can figure out what is the IP address of the server, and then how we can send messages to users that are logged onto the system, right? So let's start with df, and that tells us df is the amount of free disk space. And as you can see, this gives us in 1 KB blocks. And it also tells us where this space is mounted, and it tells us what is the capacity of the use, right? Now, this is usually for administrators who want to see how many drives have been mounted, how much is the free space, do they need to mount other stuff, and so on. For folks like us, we may be interested in du, which tells us, which gives us information about our files. So I'm just going to pipe this to more, and then see that these are all my files in my system, in my file system. And I can see how much space my files are taking up. Now, what I would like to do is first I'd like to do some file operations, and then I'd like to do some cleanup. So what is one operation that we're going to learn in this module? And that is how to use the spell checker. So let me create a file, and let me call it check spell. And here I'm going to insert this is very difficult and though interesting work. Let's do it this way. And let's see what the spell checker is going to do for us. And then I'm going to say ispell. It's with very, and then I'm going to say replace with difficult, and here let me try to give the number 2. It took that, so it did take, so I was able to accept the suggestions. And then here I'm going to say, yeah, it is a little bit stuck because it doesn't know what to do with it. And then here I'm going to say interest, and then it's come up with a lot of options. And I will say replace this, replace with interesting. And that and now it has done it. And now I'm going to do check spell. And as you can see, it has replaced. Some of the suggestions were what I picked from the numbers that it offered, and some of them I was able to give myself. I was also able to get hints from the spell checker and replace that with my own words. So that's how the spell checker works. Another thing that I could do is I could take this file and I could, seeing that everything is in lowercase, I could convert this to an uppercase file. So let's do that, and I could do dd if the in file is equal to check spell, and then I could say the out file is equal to check spell, right? And then I would also be able to make the conversion to uppercase. And here, now if I do check spell, I see that everything has been converted to uppercase. And I could just compare check spell, use the compare utility with check spell, and I see that straight off the bat in byte number 1, it's showing me a difference. It doesn't bother to check anything more because it says that the very first letter, this one is a lowercase t and this one is an uppercase t, and that is enough to say these files are very different. So these are some of the other top-level file work that you could do. And having done that, let's say we are now concerned about the disk space. We've done a lot of file work and we'd like to clean up the disk. This is super important because a lot of times when we do activities, the system creates core, which is like garbage files. And also when we compile files in, let's say, we run programs like C++, typically what happens is that the object files are created as a.out, and then we'd want to delete them. So how can we delete garbage files? So let's create some garbage files first of all. And I'm going to say create a file in my home directory, and I'm going to call it core. And then I'm going to create a file called a.out. And I'm also going to create that because I'd like to show you how you can delete the same files from, it'll start at the beginning of the home directory and keep going down the tree and go to all of the subdirectories and delete all instances of this. So you have to be really careful when you do that. So you just have to make sure that it's deleting garbage files. And then here I'm going to create source at core, and then I'm going to do touch source a.out. And when I do that, I've created these files. And now the command is slightly long, but let's kind of walk through it. And it says first of all, find dot at the top level. And then now I give, I say minus name a.out. And this minus O is actually means or. And the second name for the file that I'd like to delete is core. So a.out. I have made a mistake here. I need to add a. And then I close the bracket. And then what I've got to say is go ahead and execute the remove function. And here's what I do. And when I do that, I have, if I now see, look for core, I find that core is not there, and I do a.out, and I see that a.out has also been deleted. So this is kind of very powerful, and this is something we may want to put into a script file. The names of all of those files, temporary files that we are creating, and we want to clean up from time to time. Now, talking about cleanup, we've talked about looking at the disk space and see how that's managed. There's also a command to look at the memory usage, and you can see how many bytes of memory are available. You can also use the options to look at these numbers in megabytes and stuff. Another interesting command is to look at the CPU usage. So if we do top, this gives a list of all the processes that are running, the process ID, who's the user running it, and other details about how long it's been running and which command, i.e. which process, is actually running and what percentage of the CPU and what percentage of the memory it's being used. Now, none of my processes are running because I'm not actually running anything in the background. I'm guessing that a lot of these files are actually programs, are batch programs, which are, oh, here I am. You see, I'm running something here, but probably it's showing that I'm running the top command, but everything else is being run by the root user. Now, I do have the option to kill processes, but this is not something that I should be doing. This is something the administrator should be doing. For example, if the administrator notices that one particular process, for example, let's say my process, right here, I'm running top, as you can see. It's taken 0.1 of the memory, it's taken 0.3 of the CPU, right? That's all it's taken. But if I find that if the administrator finds that there's some process that's taking 50% of CPU and it's taking a lot of memory, it's been running for a while, then absolutely they will provide the PID. Let's say I wanted to kill 22751 is the top process. It's actually gone. I'm not using it anymore. So it says no such process, but if it were running, then it would kill it. But I cannot kill any of the root processes, right? Now, another thing to see is what are the processes that are running on my terminal. Nothing much is on my terminal. And then I say who's logged on to my terminal. The only one that's logged on is me. And it also gives the IP address of this this terminal 130.86.7. Can I message? Can I write to other users? If there were other users, I would absolutely be able to write to them. But let me see if I can write to myself. And you see, if there were other users logged onto the system, then we could talk to each other. And if I say hello, that hello is just coming back to me. But if there were lots of you logged in at the same time, then you could actually chat with each other. And that's a great feature that is offered. Now, one way, so let me end that. One of the activities that we are going to be doing here is ping. And I'm just going to do ping localhost. And as you know, ping checks the network connectivity, and then it says it checks if the connection to my local host is working. And as you see, it's constantly sending packets. And at some point, you see, at the end, it says 21 packets were transmitted. There was no packet loss, and 21 were received. So I was sending packets to myself and checking if this particular loop was working, and it looks like it was working perfectly fine. Now, after ping, the one last thing that I wanted to show you is how do I find the IP address of the server? I could just do cis.scc.losrios.edu, and here I see that it's sending messages to the Los Rios server, and that's how I got the server address, which is the IP address of the server, which is 165.196.216.12, right? And it looks like that connection is also working fine. There are also other There are also other utilities which we do not have access to. The root user or the administrator does that. For example, if config, and that's why we needed to get the IP address in the other way. If config actually did give us, so you see the 165.196.216.12, 165.1 plus 12, here is the internet address. So if config did work and it gave us the IP address. If netstats and traceroute are other utilities which are available, but they have not been installed for us, so we are unable to use it. But if we could, try some of them. So I think we have covered most of the methods that we can use to monitor disk usage, CPU usage, memory usage, and network usage. And of course, a couple of small commands which related to security are the chmod, which you are familiar with, changing the access for a file. So for example, let me see what files I have, and then I've got, let's say, ls minus l, and let's say I've got file 1, and here this file has got the owner and then the group. So the UGO, the user and the group and all others have got read access. The group has got read access. I have got read and write, and I can absolutely change that by doing chmod, let's say 777, and to file 1, and here I've got ls minus l file 1, and you will see that it has changed to read, write, execute access to all of that. The only time you need to change it to executable is if you want to make it a script file, as you know, and change and because we want to run it. So that's that. And the other is the password, which is also a security feature. I can change my password, but I do not want to do that now. So, all right.